Hello, my name is Jason Williams. You're watching another video from NJPW1. This video is all about an off-grid solar system that because I live off-grid and have done for a number of years. And these are the batteries that power the system when the sun's not shining. And obviously the panels charge during the day. Alright, so you'll see here these are C150, I think, C105, sorry, batteries. And they're like the Trojans, they're all 6 volt. And I store 12 volt, if that makes sense. So you'll see these first batteries here as a bank, small, these 2 batteries as a bank of 6. And then they're series to the next 2, which make this one bank of 4 batteries 12 volt, and exactly the same in the second lot. So it's a 12 volt bank all around. And I service these probably, or when I say service them, I top up the electrolyte probably once every month or 3 months. It's fairly well, it's not maintenance free. There is a little bit of work involved, but it's not hard. You just pop the tops and top up the electrolyte. It's pretty easy. And you'll notice grease on all the terminals. I've found over the years, I've lived like this for about 4 years with this setup, and I've lived off grid many times in the past, and I've got a fair bit of experience with them, a little bit of experience. And I've found putting grease on the terminals, once you've assembled them in the order you want them, then you put grease all over them. Wipe a nice film of grease all over the areas, because it seems to stop the corrosion to an extent. So the corrosion will is basically a type of oxidization, as well as there's electrolysis there, but it's mainly an oxidization problem. And so if you put grease on them, this suffocates the oxygen from meeting with the metallic surfaces, and that seems to stop it. I think that's how it works. So from here, I'll just briefly just show you, try to maneuver this camera to a right, the right kind of area. This is the positive coming in off the solar regulator, which I'll show you shortly. And up the other end is a black wire, and that is the negative from the solar regulator. And so I charge at the outmost parts, so the power coming in is at a different place I take the power from. And so I take the power from, as you'll see, this is the negative, that's the positive, that goes to the inverter. And them two is the only power draw I have. So we've got our power in, and we've got taking our power out at the opposite ends. This is to help balance it, because if you put power in, like say on the outsides only, and you take power out in the same place that you put the power in, you will cause these batteries to prematurely wear out before the others. So this is to help balance it. And so over here, I'll describe again briefly. I've got a big fat cable, which this joins the 2 12 volt circuits in the positive, and somewhere will be the one joining the 2 circuits of negative at 12 volt. And when I say 2 circuits, I mean 2 circuits as in these first 4 batteries is 1 circuit at 12 volt. The second set over there is a second set that's a second circuit of 12 volt. And on the end here, in the same place I put the power in, an opposite ends again, just like the power's coming in, but slightly apart, not much, is this little guy, and on the end of him is an Anderson plug. And I'll show you shortly a homemade 12 volt generator that I made. Well, someone else begun to make it, and I finished it off and made it work. And that's basically the batteries. Yes, I'll go show you the regulator now. So I forgot to mention very quickly that this is these batteries, sorry, is 225 amp hours per battery. And so if I link those four together at 6 volt, makes 900 amps. And so if we go all 8 batteries, that would be 1800 amp hours at 6 volt. But because I'm storing 12 volt, I actually have to halve that. So I've actually only got 900 amp hours of storage. And that's how it works. If you've got batteries and you go by amp hours, if you've series the batteries, if you've got, say, like this right here, 225 amp, 225 amp, if I put them two together in a series fashion, not parallel, in a series, which is this to that, like, so these two batteries, say, I have to, those 2 amp hours, because it's making 12 volt, those 2 sets of amp hours become one, not added together. So it would only be 225 amp hours, the two together at 12 volt. But if they're both in parallel at 6 volt, that would be double. You know, I'd have 225 here and 225 there. But because I've seriesed them in 12, that is now only the 225 amps. Alright, so this is the solar regulator. It's a PL80 by Plasmatronics. And this works quite well. I've used a few different ones in the past, and this is by far the most impressive. And so again, we'll see our power in from the solar panels, which will be these two here. This is from the solar panels, and this is going to the batteries. And so I can read how much I'm charging, but I've got nothing set up for the load. I've been a bit slack with that. And over here, we've got our power inverter mounted upside down, but you know, either way. And this is the other power's coming from the batteries, is these two, and that just powers the inverter, and that goes down to another little plug. And so I'll have my washing machine and fridge and freezer off there, and that one will go up the wall to another power bank where I charge all my bits and pieces, and I run lights off this as well, which is I'll quickly show you those. So this is one of the power banks that's situated next to the gas stove. So this old house is a little bit dingy, but you know, it's just and that's one of the lights. And so I just, you know, switch it on from here, and you know, that's about it. And I've got a couple of those around the house. That seems to do the job really nicely, especially cooking. And I'll show you some other lights. So I've got quite a few of these old lights from Core Lighting, which I bought many years ago. And you know, they work off a separate little 12 volt circuit that I've just got set up. But it's only a backup, you know, I don't use it very often. Well, I do a little bit, but I won't show you too much of that. Alright, so this is the little 12 volt generator. Just a petrol powered, 5 horsepower I think, something like that. And it's on a little aluminium frame that sort of holds it together. It's quite, you know, easy to start, easy to run. But I'll just move this around. And this is the little Anderson plug that plugs into those batteries. And so you start it, and it's running. And this is a alternator, like a vehicle alternator. It's a Bosch alternator that I think the number ends in 005. It's about a 70 amp alternator. And what you can do, you'll see here this weird little couple of wires and a little button here. This is called the exciter wire. And what you'll see in here, as I show you around there, this is a resistor. And so what I've done, or what's done here, is it's the power feed. So that what all I'm doing with that resistor, is tricking the alternator. I'm tricking it to think that it's at a lower voltage than what it really is. And that way the alternator works significantly harder to push the voltage higher, which makes it much more efficient. And it just runs through here, and this is the exciter wire that just excites the alternator to start working. It's all quite basic, and it's got a straight little coupling. Not that we can really see that. It's got a little rubber mounted coupling inside. I forget what the actual coupling's called, but I don't know. I might figure that out one day. It powers 70 amps, or not 70 amps straight, or immediately. Only I'll charge it around about 40 to 50 amps. I never let the batteries get low, and so I'll just top it up. Not very often, especially not summer, and I don't use it when the sun's out. When I'm washing clothes, as I'm doing a heap of washing at the moment, I'll just this is only for backup when we've had quite a few cloudy days. Alright, so these are the solar panels. There's only 4 of them. They're quite large, and this is all I use. This is all that they're all relatively north facing. They're on a bit of a slope, but I made these little brackets so I could put them all up on a bit of an angle and capture as much sun during winter and summer as possible. Right, I'll get up and show you the other bits. Alright, so this is the underneath of the panels. Sorry, it's kind of upside down, or on its side. But the majority that you want to concentrate on with a solar system is the for what panels should I be using? Well, the technology changes quite rapidly, so you'll always have good panels and you always have not so good panels. And one thing I've learnt over the years is open circuit voltage. And if we look there at the open circuit voltage, it is 21.5, I think that is, or 21.5 or 6 volts, 21.6. That's good. If that displays, basically, to me, that displays the efficiency of the panel. If that's like for storing 12 volt, because these aren't series, these panels, because you can series these as well, but these aren't, they're all in parallel. If you look at, you say for example instance, I'm storing 12 volt, and if got an open circuit of 21.6, my charge rate at low light will be quite good, and so at full light it will be very efficient. And that's basically all I look for in a panel. If I try to break down, is it monocrystal, or is it this, or is it that? Well, the technology is going to change all the time, and basically all I do is look for the open circuit current, or the open circuit voltage. And so if the open circuit voltage is good, then the rest will be it'll be efficient. That's but you do pay for what you get. Most panels around in Australian dollars, is around $1 a watt. So if this is displaying 250 watts for the panel, I think. Yeah, it's displaying 250 watts. So each panel's around about 200, or generally just below $250 per panel. All right, that's about that. All right. So while I'm sitting on the roof of this, or standing on the roof of this shed, or house, sorry, this little shack that I live in, that shed area of that shed that's directly in the middle of the screen, and that tank, that's all I'm using at the moment. I do actually have some more tanks, but I've emptied them and rolled them in the corner and ready to dispatch. I'm actually moving premises shortly. And so what happens here, all the water, how do I get my water pressure? Well, the water, there's pipes, and they run to the end of this shed. There's a pump there inside the shed, which I'll show. But I don't run that all the time. All I mainly do is pump up to the center of the screen there's a tank on top of the hill, and I'll show you that in a bit more detail, but that flows down to the house where we are under gravity pressure. So it's a gravity fed water system, and it works very well. You know, I have good water pressure here. I can run my hose, I can run a sprinkler if I need to, not that I do, but I can run the shower, and I can run, you know, I can use anything I want to. That gravity water is quite elevated compared to this house. Alright, so from this tank it's 27,000 litres, somewhere there I think, and you know, this pipe runs all the way, you know, it runs through the grass here, and actually runs up into this pump, and it's a pressure pump. And so what I'll explain here quickly is it's not, sorry about all the grass, it's not a pressure pump in this state. What I've done is removed this guy here, which is the pressure indicator that switches the pump on and off and keeps the pressure. Is you take that off, and in this instance I place it on the deck upside down because it's got a wake float valve, and it runs through this pipe and goes through under here in the grass, sorry about this, is a small check valve, which is a one-way valve, and that goes into a T. This way runs to the house, that way runs up to the tank. And so what happens is when it's pressurized, it opens this valve, like pushes it open and begins to pump water up to the tank, or, you know, even gives pressure to the house a bit. Not that that's really relevant. And this is a electric pump, obviously, and the generator for it is inside. So I'll go inside and show you that. All right. So this is the little generator that powers the water pump, and it's quite efficient. You know, it's only a very small generator, and yeah, you know, it's fairly basic. The it takes me probably about an hour from an almost empty tank to fill, drawing from the large tank to the small tank, you know, pumping up to the small tank on the top of the tank stand. This will take, this and the pump takes roughly an hour, and I'll do that generally once a month, I guess, you know, something like that. Yeah, so this once a month, and I'll check the electrolyte and the batteries probably once every 3 months. All right, that's really basic. It's a very old little generator. It works well, but I bought this, well, must have been 14 years ago at least, something like that. All right, so checking the level in the water. I normally walk up this direction to go check the level in it, but as time's gone on and I ended up buying a drone, I find myself actually flying up and having a look because, let's face it, I'm simply far too lazy. Well, no, I'm not that lazy. I do a lot of walking. I just tend to like taking my time, or, you know, finding the easiest way to do anything. That's the ultimate goal. And I'll fly over the house here, do a bit of it. You'll see me standing out the side there, and you might see swallows trying to attack the drone. If you keep watching, you'll find in the lower left there's one that passes, and then in the middle there, right there, you would have seen that. And I fly over the solar panels. You can see they're quite large panels. As you can see, as you probably watched in this video, I had a bit of a grass issue around the house, and I've employed some of the locals to come and mow the lawn. And you know, it's mainly because I don't own a lawnmower, and more to the point, I'm probably too slack to mow the lawn. You know, these guys are pretty good. You know, they don't charge much to do the job. I just supply them with grass, and they're happy with that. So this is what I've done, and you know, they do a pretty good job, really. You know, they do quite a good job. The only problem is they make a bit of a mess. They kind of leave their crap everywhere. Well, that's farm life, I guess.